Okay, welcome back to another video on my channel, math_exe. Today we're going to look at quadratic sequences and what they mean, and then later on how to find the nth term of a quadratic sequence. So basically a quadratic sequence is something like this. So if you have a sequence like 2, 4, 8, 14, 12 and so on, and then if you take the differences of the terms, and I would call that with the term of the first difference. So in this case, the difference is 2 to 4 you add 2, 4 to 8 you add 4, 8 to 4 you add 6, and then 14 to 12 you add 8, and then so on. And notice these differences are distinct. However, they form a arithmetic sequence, and what that means, if you take the difference of the differences, or in this case I would call it with the term of second difference, that second difference will be constant throughout the whole sequence. So that's basically the definition of a quadratic sequence. And basically a quadratic sequence is a sequence that when you take the second difference, or possibly the difference of the difference, or whatever term you like to call it, that second difference will be constant throughout the whole sequence, meaning it all will be always the same. And another fancy way to write the definition is to write them in kind of like a algebraic form. So we have T1, T2, T3, T4. These terms are the first four terms of a quadratic sequence, and when you take the differences between them, they form distinct differences that form a arithmetic sequence, meaning that if you take the difference of the difference, this second difference, I would call it, will be constant, meaning it will be the same. So how do you find the nth term of a quadratic sequence? And that is related to why I introduced the term second difference, because it has something to do with this. So let's just find the nth term of this sequence. So we have 2, 4, 8, 14, 12. I'll just write the sequence right here to keep track of this. There we go. Alright, so we know the second difference is 2. And what I'll do is I'll take the second difference and then multiply it by a half. So that number will be just 1. And this one will be the coefficient of n squared, as I've written it here. And there's a reason why this is called a quadratic sequence, is because the nth term, the formula for the nth term, will consist of a quadratic expression. So you take the second difference and then multiply by a half, and then take that as the coefficient of n squared. And then you may write the first like 5 or 4 terms of this, possibly as many as you want. However, not I would suggest not too many. So the first term will be n equals 1, substitute that into here, so I have 1. Second term will be n equals 2, that will be 4. Third term, n equals 3, that will be 9, and then you can just continue the sequence. And I'll just stop here. And I'll know these terms, this first term and this first term. And you may think to yourself, what number must I need to add to this term 1 to get this term 2? Because you need to find the formula for this, and of course you need to find what number you need to add for this. And then you can just do this for each term, and then you just ask yourself about this. Alright, And I'll just write this with difference. So the difference between 1 and 2, you need to add 1 to get 2. From 4 to 4 is just 0. From 9 to 8, you actually need to subtract 1. 16 to 4, negative 2, negative 3. And then you can just continue the sequence. And notice this forms a arithmetic sequence once again. So we can find the formula using Tn. Actually, I'm not call this capital Tn, I'll just call it little tn. This will be the first term, which is positive 1 plus n minus 1 times the difference. In this case, is negative 1. Because we subtract by 1 to get the next term. After doing this, you'll get 1 minus n plus 1, or just negative n plus 2. So the formula for the difference of these two sequences will be negative n plus 2. And at this point, you are pretty much done, because what you need to do is to just add this original formula to this formula right here. So the final nth term for the quadratic sequence will be n squared minus n plus 2. And this is just basically it for the formula for the nth term of the sequence. And you can just try it by yourself, substituting n equals 1. The first term, you will get 2. And the second term, you will get 4. And then you can just do that testing, sort of. So actually you can kind of like generalize this with a formula. However, that would be too difficult, and you might get a bit scribbled out. Anyways, that's all I have to say about the nth term of the sequence and what a quadratic sequence is. So let's jump into some examples. For the first question, you need to find the 100th term of the following sequence. So we have 3, 4, 7, 12, 19. So first we can just find the second difference of this sequence. So we have 3, 4, 7, 12, 19. Notice if you check the differences, you get positive 1, positive 3, positive 5, and positive 7, and so on. Taking the second difference, you get this will be plus 2. And like the technique that I've talked to you before, take the second difference and then multiply by half, and then set that as the coefficient of n squared. So in this case, a half of 2 is just 1, and then the coefficient of n squared is just 1. And then from here, you can just write the sequence for 1n squared, which is just 1, 4, 9, 16. And then you can just check this sequence by substituting n values for this. I'll just stop this as on the first 5 terms of the sequence. And then look at the difference right here. So you need to find what you need to add to this sequence to each term to get the corresponding term in the original sequence. So checking this, the difference for the first term will be positive 2, since you need to add 2 to 1 to get 3. From here, the second difference for the second term will be 0, since 4 is just 4, you don't need to add or subtract anything. And then from 9 to 7, you actually need to subtract 2. And then from 16 to 12, you need to subtract 4, and then you can just discover the pattern right here. You just subtract 6, and so on. With this, you can find the formula for the difference, which is just I just call it little tn is equal to first term, which is 2, plus n minus 1 times the difference, which is just negative 2. Simplifying this, you'll get this will be equal to 2n, negative 2n plus 4. So the formula for this is negative 2n plus 4. And then you need to add this formula with this formula. So you get the final and not the final answer. The formula for the nth term of the sequence will be n squared minus 2 plus 4. And then what's the question asking us is the 100th term. So T of 100, just substitute n equals 100 for this. So 100 squared. I'll just erase these things right here. We don't really need them for this. So if 100 squared minus 2 times 100 plus 4, 100 squared will be 10,000. 2 times 100, 200 plus 4. This will be equal to 9,804. And that is the final answer for this problem. So anyways, let's get into the second and probably last example. The sequence 4, 8, 16, 28, and 44. And first, part A, we need to find the nth term of the sequence. So let's just find the second difference of this. So let's just take the differences, and we already know this will be distinct. And next, we can just take the difference of the differences, and it will be constant, and it will be positive 4. And like I have done in the previous steps, let's take the 4 and then multiply by a half. And this will be the coefficient of 2, I mean the n squared, sorry. So it's just right here. And a half of 4 is just 2. So the coefficient of n squared in this case is 2. And from here we can just write the first couple of terms of this sequence with the formula of 2n squared. So those terms will be 2, 8, 18, 32, and 50. And then compare the each term of this sequence with the original sequence, and then find out the differences. So the difference between perhaps I shouldn't say difference. I would say what to add or subtract to these terms in this sequence to get these terms in this sequence, and those numbers will be as so. So what you need to add to get 4 is just positive 2. What you need to get 8 is just 0. And then what you need to add 18 to get 16 is you need to subtract by 2. And then you can just do this, and you can just see where this is going and what is the pattern right here. Alright, and we can just use the formula for this. Formula will be, I'll just call it little t of n. This will be equal to the first term using the arithmetic sequence formula. The first term is just 2 plus n minus 1 times the difference, which is negative 2. Simplifying this, you'll get this will be equal to negative 2n plus 4. Alright, and from here we're just pretty much done for part A, because we can just combine this formula with this formula to get the final answer for part A. The t of n is 2n squared minus 2n plus 4. Alright, and part B is pretty interesting. Find the value of m if the mth term of the sequence is 4904. So we can just set up an equation. T of m is equal to 4904. And then using this formula above, alright, and perhaps you can just switch this into a quadratic equation. So subtracting by 4904 on both sides, you get 2m squared minus 2m minus 4900 is equal to 0. And then if you want to make the number smaller, you can just divide all of this by 2. So on the left hand side, we can just first factor out a 2 and then later on divide the 2, so the 2 will cancel out. So we're left with m squared minus 2m minus 4800 divided by 2 will be 2450, and actually the 2 will be gone on here, sorry. It's equal to 0 divided by 2, which is just 0. And then from here, you can either try to factor this quadratic expression or by completing the square possibly, or by using the quadratic formula. However, I'm not going to do that. But what you will get is m will be equal to 50. And you may be wondering, well, aren't there supposed to be 2 values of this quadratic equation? Well, yes, but we can reject the other one because the other one, let's just call this m1, the other root of this quadratic equation is actually negative, and you may guess that negative orders are unreal and doesn't make any sense, so we can just reject them. So the only actual and possible solution is m1, or let's say m is equal to 50. So that's it for today's video. Hopefully you guys enjoyed this. Please subscribe for more, and I'll see you guys in the next one. Goodbye.